Hello. In today's maths question, we will be looking at vehicle suspension. Specifically, we'll be looking at the motion of the wheels moving up and down in relation to the vehicle. So the question says, the vertical motion of the suspension system of a motor vehicle may be represented by this function, where y centimeters is the displacement from the center of oscillation at time t seconds. When t equals pi over 4 seconds, calculate the displacement, the velocity, and the acceleration. So you can see we've highlighted the key information in red. So what does this relationship between y and t look like? Well, we see it's a combination of an exponential decaying function and a periodic function. So we see that the function is oscillating, but it's also decaying. Part A asks us to find the displacement when t equals pi and 4 seconds. Representing this graphically, we see we have the purple line, which is our function. Solving this is then simply going to the value t equals pi and 4, taking that up to our function, and reading off the value of the function at the point t equals pi on 4. So doing that, we see that the value of the function is somewhere between 0.2 and 0.3. To solve part A algebraically, we take our function and substitute in the value t equals pi over 4. We see that after substituting, we find that y equals 0.242. We need to make sure that we answer the question that was posed. So interpreting this, we say that when t equals pi over 4 seconds, the displacement of the suspension is 0.242 centimeters. Part B of the problem asks us to find the velocity when t equals pi over 4 seconds. To do this, we have plotted the purple line to represent y as a function of t. So to find the velocity, we need to find the rate of change with respect to displacement. So the rate of change tells us that we need to find the gradient, while the gradient helps us find the rate of change. So all we need to do is find the gradient at t equals pi over 4 seconds. So if we look at our purple line, the function, we can draw a tangent line, and this will allow us to calculate the gradient. We see that the gradient is in terms of centimeters per second, which makes sense since we're trying to find a velocity. To solve B algebraically, we need to take the derivative of the function using the product rule, and then we need to substitute in the value t equals pi over 4. Jumping to the answer, we see that dy dt equals 0.435. We need to interpret this number in terms of the question of how it was posed. Therefore, we say that when t equals pi over 4, the velocity of the suspension system equals 0.435 centimeters in the positive direction. The positive direction means that the velocity is up. Part C asks us to find the acceleration when t equals pi over 4 seconds. We know that acceleration is the rate of change of velocity. We calculated the velocity in Part B, so we will build off of the work in Part B. We know that we calculated the function dy dt. We can now plot that function as I have done here with the green line. Then all we need to do is query the point t equals pi over 4 and find the rate of change, just like we did in Part B. So the rate of change is the gradient, as we're all aware. And as we can see here, it is negative. We can now solve this algebraically. Solving Part C is similar to solving Part B. We take the derivative of dy dt using the product rule, then we substitute the value t equals pi over 4, and jumping straight to the answer, we see that d2y dt squared equals negative 1.151. We need to interpret this in terms of the question. So we say that when t equals pi over 4, the acceleration of the suspension system is negative 1.151 centimeters per second squared. That is, that the system's velocity is decreasing or slowing down. We see that if we go back to the graph. Looking at the point B, and we look just a little bit to the left of it, we see that the gradient would be steeper, and therefore the acceleration would be more. If we go just after the point B, we see that the gradient is flatter, or that the acceleration will be less. So as we move past the point B, we do see that the acceleration is decreasing. In summary, we investigated our periodic exponentially decaying function by graphing it. We then investigated displacement. We then looked at velocity as being the rate of change of displacement. And finally, we looked at acceleration as being the rate of change of velocity. Thank you.